The sulfide 2 negative anion, the chloride 1 negative anion, and the potassium 1 positive cation, they all have the same number of electrons, yet they're all different sizes. So why is that? First, let's take a look at how these end up with the same number of electrons. Sulfur is here, number 16 on the periodic table, and a neutral sulfur atom becomes a 2 negative anion by gaining 2 electrons. It'll end up with 18 electrons. Now chlorine is right next to it with 17 electrons in the neutral chlorine atom, and by gaining an extra electron, it becomes a 1 negative anion. Again, also has 18 electrons. Potassium is in the next period, number 19. Potassium can lose an electron and become a 1 positive cation, also with 18 electrons. All three of these ions have the same number of electrons as argon. We say that they're isoelectronic to each other. They have the same electron configuration. So why is it that all three of these have the same number of electrons, 18, yet are all different sizes? Now, I hope you're thinking that this is a silly question, because you know the electrons alone don't determine an atom or ion size. We know that electrons on their own repel each other, so we have to consider what's holding them together. The attraction that's holding these electrons together is called the nuclear charge, the positively charged protons in the nucleus. Now that's different for each of these ions. Sulfur has a nuclear charge of 16 from its 16 protons. Chlorine has a nuclear charge of 17. And potassium, 19. Therefore, we can say the potassium cation is the smallest ion because it has 19 protons attracting those 18 electrons inward. And we can conclude that the sulfide anion is the largest ion of the three because it only has 16 protons. Relative to the other two, the sulfide ion has the smallest nuclear charge. And we can expect the chloride ion to be in the middle between the two because it has 17 protons, which is between 16 and 19. Now consider one more thing. Do you think the chloride ion will be closer in size to the sulfide ion or the potassium ion? And why? Well, hopefully you're thinking because 17 is one more proton than 16, the size of the chloride ion should be closer to the sulfide ion. In other words, 17 protons is 2 less than 19. The size difference should be greater between the chloride and the potassium ions. And the measurements given in the problem agree with those expectations.